Hello, everyone. We are going to be talking about statistics today. So, you're going to have a little bit of an introduction into statistics. I know this is not a statistics course, we're talking about Algebra 1. But there's some things we learned last time that helps us learn and know what to do with statistics. So, we have two goals today. One is we're going to analyze data. And the second thing is we're going to determine what makes graphs misleading. And we're going to talk about a bunch of different graphs today. Alright, let's go ahead and dive in. Let's look at a definition. Bar graph. What is a bar graph? So this compares different categories. Ooh, got a little sloppy there. Different categories of, whoa, I gotta be careful here. Okay. Of numerical information by showing each category as a bar whose length is related to the frequency. All right, so let's look at some data. We have some college sports data of participation in the sports. All right, we're going to be looking at the year. And we're going to be looking at men and women's sports. And if you know anything about this, this has been highly in the news lately. Alright, so we're going to look at 1996, 1997, 1998, and 1999. Alright, and we'll see how many people were participating in the sports. Alright, so in 1996 we had 206,000. 97, 199,000. 1998, 200,000. 1999, 208,000. Let's look at the women. We had in 96, 125,000. 1997, 129,000. 1998, 133,000. And 1999, 146,000. Alright, so we want to represent this information with a bar graph. So let's do that. So we got our vertical and horizontal axes. And on the left, we want to have the number of participants. Okay, and we'll say this is 50,000, this is 100,000, 150,000, 200,000, 250,000. All right, and then we're going to list the years down here. We got 1996, 1997, 1998, and 1999. All right. So we are going to make blue for men and red for women on the bar chart, bar graph. All right. So we had 206,000 men in 1996. All right. And in 1997, we had 199,000. In 1998, we had exactly 200,000. 1999, we had 208,000. All right. Now, let's look at the women. We had 125,000 in 1996. In 1997, we had 129,000. In 1998, we had 133,000. And then we had 146,000 in 1999. All right. So, what do we want to do here? We want to know about how many more men than women participated in 1998. So if we look at our table, we don't even have to look at the bar graph. We could do 200,000 minus 133,000. So 200,000 minus 133,000. Well, that's 67,000. All right, let's look at another question here. What was the total amount of participants in 1999? So 1999, we would need to sum together 208,000 plus 146,000, right? So 208,000 plus 146,000. This is 354,000. All right, so these questions we can answer without the bar graph. We can just look at the table. But let's look at something that is a little bit more visual appealing by looking at the bar graph. What can we say about the men from year to year? Well, if I draw here in green the tops of these, they all are about the same. There's not much difference. But let's look at the women. It looks like they just gradually increase. Right? So there are more and more women getting involved with college sports over time, whereas the men, it remains about the same. So we can see that trend with this bar graph. So that's a really nice thing about having a visual to be able to see this information. It's harder to tell that with the numbers. All right, let's look at another definition. Circle graph. All right, what does this do? It compares parts of a set of data as a percent of the whole set. Sometimes you'll hear this called a pie chart because it's circular like a pie, and it looks like you're taking chunks of the pie, different size pieces of the pie out of the pie. And we all love pie, right? All right, so let's look at one here. And So we're going to say this is 1%, not sure. This is 64% worse. This is 7% better, and I know my pie chart doesn't look that accurate. And this is 28% same. These were the answers of a survey. And what was the survey? The survey was, is NASCAR ignition better than NASCAR Heat 5? And people could replace this word better with worse, not sure, or same. Okay, so they could replace this word here. So this is what people answered. And this is made up, this is not true data. This is just an example. So let's ask a question here. If 4,000 people were surveyed, how many felt NASCAR ignition was better? So if we take over here, we have 7% said is better. So if we take 0.07, which is 7%, multiply that by 4,000, we get 280 people said it was better. All right, let's ask another question. Let's say if we surveyed 600,000 people. So if 600,000 were surveyed, how many would feel it was worse? So how many would feel NASCAR ignition was worse than Heat 5? So we look up here and we see that 64% said that they felt like it was worse. So 0.64 times the number surveyed, 600,000. This is 384,000. All right. So if there's any point in time that you feel like I'm going too fast, you can always pause and rewind and rewatch some parts, and that will help you keep up. There's nothing wrong with that. I did the same thing when I was watching YouTube videos from other people and trying to learn a topic. All right, let's look at another kind of graph. We have a line graph. What does this do? It shows a set of data changes over another variable. Now, I do have a bit of a guide for this stuff, and I kind of disagreed. It said over time, and you're not always comparing with time in the scientific world, but they like to use the independent variable as time quite a bit in the literature I'm working from. But being in my profession, I don't really like using time as always as the other variable that we're comparing with. So let's take a look at this type of graph. All right. So we have some students enrolled, and this is the number of enrolled students in the millions. And again, this is made up data. This is not necessarily true. And this has to do with the graduate engineers. So those engineers that get graduate degrees. And we're looking at a course of years here. 2005, 2010, 2015, and 2020. And we're going to plot got a little crowded here. Yep. How many millions of students were enrolled? Okay. So in 2005, let's say there were about 1.2 million. In 2010, let's say that there were about 1.35 million. And then 2015, let's say that there was about 1.55 million. And let's say there were 1.6 million in 2020. All right, so what do we need to do? We want to estimate, and let's connect these dots actually with some lines. So we want to estimate the enrollment change from 2005 to 2015. All right, so let's look at this line graph. And how many did we have in 2015? We had about 1.55 million. And then how many we have in 2005? We had 1.3 million. So if we subtract these, we get 0.25 million. So that's about the change. Now we're estimating because these dots are not exactly lining up with a certain tick mark here on the left vertical axis. All right, let's look at another question, or statement in this case. We want to predict the enrollment in 2025. We're predicting. We can't predict the past, we can predict the future. We already know the past. If the growth continues as 2015 to 2020. All right, so what we're going to do is assume that this change here from 2015 to 2020 is going to continue for 2025 out here. Okay, so we're trying to figure out where are we going to be. So if we take 2020 and subtract 2015, so we look at this and we have at 2020 we have 1.6 million minus 1.55 million. That's equal to 0.05 million. Okay, so if we add that to this 1.6 million plus 0.05 million, we would estimate then there would be 1.65 million students enrolled. All right, so let's do a little bit of review here of the types of graphs and when to use these graphs. All right, so let's look at bar, circle, and line graphs. Okay, so when we want to use a bar graph, this is when we are comparing different categories of data. Okay, and when we want to use a circle, it's when we want to show data as parts of a whole set of data. Remember, it's a piece of the pie. And then, when do we want to use a line graph? When we want to show the change in data over another variable. And again, this text I'm working from says over time, but it could be any other variable. All right, now this covers part one of what we're trying to learn today, how to analyze data with these three kinds of graphs. Now, we want to look at the topic number 2, how to identify misleading graphs. So, ways to identify misleading graphs. All right. Oh, I got a little sloppy over here. Okay. So, what is one way? Well, if they have numbers that are omitted on the axes and there's no break shown, this can be confusing and misleading. Second, if the tick marks, you remember the tick marks that are on the axes, if they are not the same distance apart. So if there's some that have larger and smaller distances between each tick mark, that can be very confusing for the person looking at the data. And last, this only applies to the circle graphs, the pie charts. So the circle graphs do not add up to 100%. If you're dealing with 99% of the data, what's happening with the other 1%? If you're dealing with 80% of the data, what's happening with the other 20%? No one knows. It's confusing. So we don't want to do that. We want to make sure that everything always adds up to 100%. All right, so let's look at some problems here. And we have a bar chart, or bar graph. And remember last time the bars went vertical. Well, you can have bars that go horizontal. And let's see that, okay? Oh, I'm going too far. All right. So you're like, what are we drawing? So these numbers indicate how far over this goes. And this is a number of participating colleges. And these are the sports. Okay, so we have basketball, baseball, and tennis. All right, so this lists how many, this is made up data again. This is how many sports that are participating or how many colleges are participating in each sport. So let's look at some questions here. All right. We want to know how many schools offer basketball how many more schools than baseball. Alright, so how many more schools offer basketball than baseball? So over here we see basketball, here we see baseball. And that associates with each of these two bar charts. And here's the total amount here. So what we need to do is we need to take 321 minus 285. And that's how many more? So that would be 36. So the distance between here and here must be 36. Alright, let's answer another question. What sport is offered at the fewest schools? Alright, so if we look here at basketball, there's 321. If we look here at baseball, there's 285. If we look at tennis, there's 276. So we have to find the smallest number. Alright, let's start comparing. Is 321 or 285 smaller? I'll let you answer. If you said 285, that's right. Now, which one's smaller between 285 and 276? 276. So which sport is 276 for? Tennis. Right. So tennis would be the answer. Alright, let's look at one last graph here. Alright, and what we're looking at are low temperatures. And low temperatures are very important in my field. And so we have minus 45, minus 40, minus 35, minus 30, minus 25. Okay, and we're going to look at different days. So we're on day 1, day 2, day 3, and day 4. Alright, and we're going to look at the data here. So this is going to be a line graph. We're going to connect these dots with the lines. Alright, let's see what our questions are. Which 2 days had the greatest increase in temperature? So what do we mean by increase? It goes up, right? It gets warmer. Okay, so we're dealing negative numbers here. So which one is bigger, negative 25 or negative 45? If you said negative 25, you're right, that is warmer. So we're dealing with some very, very cold temperatures here. And in some countries, we do see these cold temperatures. The farther you get from the equator, it increases your odds. So let's look at which ones increase. So day 1 to day 2, that actually decreases. So that's not an increase. Day 2 to 3, it looks like we change a little bit. and day 3 to 4 it increases by a lot more, right? So we would say day 3 to 4. All right, let's look at another question here. Which graph is this? And I think I already gave you the answer. Do you remember what the answer is? This is a line graph. That's right. Okay, well, I hope you enjoyed this lesson today. And if you did, please hit the like button. If you have any comments or questions, please let me know and I'll try to answer them. If you enjoy the channel, please subscribe. We need all the subscribers we can get. And I will see you next time.